Dun, 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 dun. Okay. All right. Okay. Hello. Hi. Truth is, I already kind of streamed this whole thing, but the microphone was turned off for a couple minutes, so I kind of restarted the entire thing. So we're gonna start back up. We're gonna do this little introduction yet again. I started working already. But you don't know what any of this means, right? Okay, wait. Let me restart the top camera because this baby is getting a bit of delay. Okay, so what we have been doing yesterday. I have a bunch of shit everywhere now, but this is coming. It is coming soon. First, let's put everything back into its own little pouch to be a very organized sweatshop, Chinese electronic sweatshop. Fuck that. Okay. So yesterday, I left you with quite a lot of things that went on. So let's start back from the beginning. What are we doing? What is the entire concept that we are exploring right now? This is the concept. It is, I have the opportunity to create a big piece for Monaco, the Principality of Monaco. So this is a big table, 1.5 meters approximately in length. And if I remember correctly, my measurements, around 60 meters in width and 90 centimeters, all centimeters, obviously, not 70 meters, 70 centimeters of width and 90 centimeters of height. So a big, pretty fucking big table, pretty girly table. And on top of those sit those rectangles that originally we thought were gonna be epoxy, but it turns out we're not gonna do epoxy because epoxy fucking sucks. We poured a bit of epoxy in steel tubes, and it turned out the steel tubes kind of have the epoxy inside now, but they will never let it go. However hard I try. It looks good, but there's a bunch of bubbles in there as well. So it was just too many problems to make sense, right? So what I ended up doing is going to the nearest city that has hardware stores and fucking material stores and shit like that. And I found a provider for acrylic. These little fuckers, right? This is 12.25 centimeters of acrylic. If I'm not mistaken. It cost me, actually I paid for 4 of those, 50 centimeters. It cost me 163 euros. 163 euros for 50 centimeters of acrylic. That's quite a bit of a markup for them. But it looks much better, especially once it's processed. There we go. Got it already. Than the original epoxy. So this is processed acrylic, 120 grit, if I judge it correctly. And you see the diffusion of light is just gorgeous, right? There we go. That's the idea. That's what we're going for. Okay. So these are going to be the rectangles that are on top of that little map. Whoop, wrong side. That little map over there. And LED strips are going to be from under, lighting it from under, so that it kind of glows. It's kind of pretty. And why is it light interactive? It is reactive and interactive because every time there's going to be an event in Monaco, that section where the event is happening is going to glow a different color, whether red for the Grand Prix, the Formula 1 track, blue for the yacht show, a bunch of different shit where it's happening, which is, I think, pretty fucking cool if you actually believe me. And yeah, that's the entire thing. So yesterday what we did is we processed those acrylic tubes and we made a little mock-up. So I made the visuals a couple days ago before starting the streaming whole follow. I made this little baby over there that you can see in the bottom right. I'm actually gonna make the bottom right camera a bit bigger. This little baby, right? So it is all modular in the sense that those are all walls that you can take off and on. And I made the support structure under. So there's 2 layers. As you can see from the visuals, there is a metal outline. I don't know if you see it. There's a metal sheet outline of Monaco, and under is the wooden table, right? And under the wooden table, there's gonna be supports so that the thing don't fucking blow up. I think you might want to see this more. Let's do it. Yeah, let's do it this way. Yeah, let's do it this way. Yeah, fuck it. Right. So this whole thing is modular. Anyways, so this would be the black is the table basically, and under those are the supports for the rectangles. So if you look at it very clearly, you can see that there's little nudges in the corners. That means that when you put a little rectangle inside, only the corners are supported, which allows for more light to come through, because the light's going to be light's going to be shining from under, and the goal is to hit as much of the acrylic rectangle as possible to make it look sexy and pretty and everything. We need more light. I'm in it's fucking dark in here. Oh Jesus! Oh, it's getting dark already. Ooh wee! Ooh, more light. Ooh wee! Wait. Wrong side. Fuck that. Yeah. Okay, that looks sexy. Now we're talking. Now we're fucking talking. Yeah. All right. Yeah. There we go. So. Basically, it's going to be shone from, shone. I don't know why I keep, maybe it's an actual word, whatever, shining from under, and it's going to look sexy. And I made all the supports yesterday, printed everything, we designed everything on stream, and then I printed it, and then I assembled it, and yeah, it can be assembled and disassembled. Every piece is printed by itself and then connected through, you guessed it, connectors. The walls, same, they kind of clip into place from the side here and from the other side here, and then they're kind of there, and then you can kind of put the additional walls on top. There's a bunch of shit under, and it kind of clips in, and it's fucking cool. And it took me approximately 1.5 hours of designing yesterday, but that is the current idea. And the supports from on the side supports from on Jesus Christ, the side supports that you saw under that only support the corners, that is looking pretty promising for the final version. I don't know yet, but we'll see. And so I don't have my phone. Oh, I don't have the LEDs yet. And so anyways, this is structural advancement as well as material testing. I still haven't tested all the grits of sanding to see which one looks better, best. I did a bit of testing, but not that much. But today I received a bunch of electronics, which is extremely exciting because that's the part I enjoy doing the most. And so, as you can see from here, there's a bunch of electronics pretty much everywhere. And I mentioned that I started doing streaming before, and my mic was off. So I did a bit of streaming electronics explanation as well as wire explanation, wire gauge. So we're gonna do that again because it's actually pretty fucking interesting. Right now. Yeah, there we go. So, Sketchpad. So, how is this all going to work, you may be asking? It's pretty fucking simple, mate. It's pretty fucking straightforward, bro. Right. You may leave. The way this is gonna work is, I have. You can have a bit more music. Let's not be too shy about the music. that would be lame. I have basically this. This is. This is an AC plug that also has a fuse built in, as well as an EMI filter, electromagnetic interference filter. This will be plugged into the wall. And the output is going to be those 3 pins. So we have a line, neutral, and ground, if I'm not completely stupid. I never worked with alternate current before. I only work with DC, direct current. Alternate current is what's in your wall, direct current is what's in your electronics. Pretty much, I think that sounds all right. Your home appliances. I don't know what home appliances are. Anyways, it's just easier to transport alternate current over large distances. That's why this is what is used in the power grid. And then direct current is used in your small electronic appliances, such as your computer, your phone, and everything. And we're going to use direct current for the LEDs that are powering the entire thing. I need water. I'm fucking thirsty, man. Okay. Yeah, buddy. Okay, so now AC is going to get into this, and then it's going to run through a power supply. Yeah, bud, a power supply. That's a power supply. We like power supplies. That turns AC 230, 240 volts. That's what's in our walls in Europe, into 24 volts. 24 volts direct current, which is what the LEDs are going to be asking for. I have LED strips that are going to be under the rectangles that you saw earlier. They're going to be powered by 24 volts. 24 volts, I think, is enough that if you touch it, you get all, woo, you feel it. 5 volts, you don't feel it, because the skin is basically resistance. You have skin resistance. If your skin is wet, lower voltage is going to fuck you. If your skin is dry and thick, you have more resistance to voltages. But I think 24 is already kind of dangerous zone. I'm not completely sure, but I'm not going to risk touching it. To the point. The point being, this 24 volt power supply is going to need wires, right? Fucking wires, to transport the electricity from it to the LEDs, right? And also from the AC plug to the power supply, right? That sounds pretty simple, this part. We need wires, plug the wall, plug with this cable. This is a plug wall in France. So plug that into the wall, whoop, and then this plugs into the this AC fucking thingy, this fucking plug or whatever the fuck you want to call it, and then it comes out of those and goes into the power supply. Now, I don't see if I have any. Music is a bit too loud. Thank you, buddy. Thank you. I'm gonna put it down. Thank you. If you were here an hour ago, you would have told me that my microphone was off, and that would have saved me an hour of explanation that didn't get anywhere. How's the vertical stream? It's all right, I guess. I don't know. It's a bit fucky. I don't know why I have this option enabled. Anyways, sorry, sidetracked. Sidetracked back into Sketchpad. Yes. Okay. Yeah. Right. So, wall into plug into power supply unit into LED. Now, there's those things that are called fuses. What are fuses? Fuses are little things that make sure that if the current is too high, so amps, a fuse, so a wire, basically burns instead of your electrical appliances. So if my LEDs, we don't need a Sketchpad for now. My LEDs, which are running on 24 volts, yeah, right, on 24 volts, are going to be pulling a certain amount of watts, which is energy-ish. To do that, watts are calculated volts times amps. Amps fuck up your wires if they're too high. They burn the wires, they burn your electrical appliances, they burn pretty much anything. So what you use to prevent that, if there's a spike, a surge of amps, is fuses. Fuses are going to burn instead of your wire and your electrical appliances. So we have, ladies and gentlemen, I present to you a fuse box. This is usually used in fucking cars. Yeah, that's a fucking car fuse box. It can take 12 to 24 volts. And basically what you do with this is you put tiny little blade fuses, which are those things, in there. And so each of your LED channels are going to be connected to those little outputs, and the input of 24 volts from the power supply is going to be connected to the top and bottom, right? Since I know MG's in the chat, maybe I should keep the chat open. There we go. There we go. So, the concept is extremely simple. We're gonna have a bunch of fuses for each and every LED channel, so that if there's anything that breaks it, If there's anything that happens, the fuse is gonna burn instead of the LED. So we have our circuit, pretty much. I'm also going to show you, this is a 15 amp fuse. I think I can pull out 15 amps with my bench power supply, which is a power supply that you can basically control with little knobs. And I happen to have one right fucking here. Right, I was prepared because I did it already. Oh, it's fucking amazing, it's fucking great. Now I'm gonna take this, put it up to 24 volts. And as I said earlier, no, this is a 15, I want a 10. It's a bit safer, so I don't fucking die. Right, this is a 10 amp fuse. And if I connect it to my bench power supply right here with 24 volts, if I run 6.7 amps into it, nothing fucking happens, right? However, if I run it up over 10 amps, so we go up, we go up, we go up, we go up. I don't think it burned. I don't think I can go higher than 10.2. Nothing happens because 10.2. So what we're gonna do is we're gonna fucking turn it off and sacrifice a 5 amp fuse. So 10.2 is still a bit too low for a 10 amp fuse to burn. But if I connect a 5 amp fuse and run it, it's gonna be fun. That shit burned. It burnt a little bit of smoke and it's been burned. And so it's not connected anymore. Isn't that fun? It's burnt. And so current is not passing through anymore because the wire is burnt, all right? This is the whole concept of fuses. Anyways, so we're gonna do wall plug into power supply unit, which is gonna output 24 volts, into fuse box, into LED strips that I do not have yet, which is, some people would say problematic. I would call it boring, and it's gonna take another week for them to come here. So, back to our horses. Why do I have all these nerd-ass calculations on the sketch pad right here? There we go. It is because each of these power supply can supply up to 350 watts. Now, the important part is that watts are volts times amps. We know how many volts are coming in and we know how many volts are coming out. In, it's around 230 volts. So to supply 350 watts, and I like to be conservative, so add a bit more, so 400 watts, just to be safe, I'm gonna need, let's make myself smaller, I'm gonna need 1.75 amps to supply the 400 watts. 1.75 amps is not that much. If you look at, I'm talking about wires now, so if you look at the wire gauge, 1.575 amps is decimal equivalent, gauge size. I want to know what's the maximum amps you can take. Max amps. There we go. So 1.75 amps can be done by 28 AWG gauge, which looks, 28, I don't have any because they're so fucking thin. But let's say that's 24, right? This is a 23 even. This is a 23 AWG 23 wire, which is really thin. However, when it comes out as a 24 volt current, energy, whatever, to get up to that 400 watts, right? That 24 volts is gonna need to be 16.6 amps. 16.6 amps is starting to get into dangerous territory, right? 16.6, I'm gonna need something more than AWG 14. The only thing I have is AWG 14. I tend to be conservative, that's why my calculation is done with 400 watts, but if you do 350 watts, which is the actual max that this is gonna be able to output, which is equal to, so for 24 volts, that's going to be 350 divided by 24. That's 14.5. 14.5. Whoop. 14. Whoop. 14.5. So if we look at it, 14.5 is within the range of AWG14, which is the biggest wire I have. So to be safe, I should be using something bigger, but also I'm not going to output all 350 watts into this single wire. So I think we're fine. Isn't 400 watts way too much for those few LEDs you're planning to light up? Yes, sir, it absolutely is, but it is not a few LEDs. We're talking about, what the fuck am I looking at this? We're talking about approximately 18 meters of RGBW LEDs. RGBW means we have R, red, G, green, B, blue, as well as a white LED so that we have a lot of brightness. We have 18 meters of those. It's a big table, it's 1.5 meters. And I'm thinking about 15 channels of LED under. That is a lot of wattage that we're gonna need. I'm not gonna pull, and I'm actually gonna use, this is a little bit for later, but I'm gonna use 2 power supply units because I want to balance the load decently and have a bit of headroom. If people actually want more brightness, I could change the LED afterwards. That's to be decided when I show the prototype to the client. Not the prototype, the MVP, minimum viable product, to the client. That's to see later, basically. But yeah, it is 400 watts is a lot. That is for sure. Now, where was I? Yeah. So that's all to say that wires need to be chosen very safely. And as I'm saying that, I'm using AWG14, which is barely enough for what I want to do if I was dumping all 350 watts at 224 volts in them individually, which I'm not going to do. Each power supply is going to have 2 channels going into the same fuse box, which means the load should be balanced relatively evenly. And each power supply is never going to get to 350 watts. But if it did, nothing would burn. That's the main thing that I want to make sure of. That's pretty much all I have in terms of explanation. And that's where I pretty much ended at the last stream, the one where I didn't have a mic on. Are we good? We're good. Okay. So what we're gonna do, is we're gonna go in there and we are going to look at the whole circuit. So the circuit is as such. We said wall into power supply unit, into fuse box, into LEDs. The scary part in there is power supply unit to fuse box, because those are 24 volts. And we said there's quite a lot of amperage, almost 14, maybe 15 at full power, which I'm never going to get again. To do that, we need those AWG14 wires, which are pretty fucking thick wires, and we are going to use those connectors. So what I did that on stream, but I removed the insulation from the wires, I put in those connectors, and then I crimped them, so I basically crunched them, put the connectors on the nude wire, I don't know if you say nude wire, and I crunched it so that it fucking sticks. That's the pro way to do that shit. On the other side of those wires, so let's look at the top-down camera. Whoop. The connectors that we just looked at are going to be crunched under these screw terminals. So basically, I'm going to screw this. Boom, boom, boom. Oop. Boom, boom, boom. This is screwed and this is not going absolutely anywhere, right? The other side of that wire is going to go into the fuse box. The fuse box terminal is a screw, basically, with a bolt on it. The way those work is, first of all, I'm gonna have to unscrew that motherfucker. There's no way I can unscrew this, right? Oh yeah, there we go. Shit, come on. The way those motherfuckers work, right, is you don't just put your wire in there. The way you do it is, there's a bunch of washers. I'm not sure exactly how to use it, but The way you do that is you take those ring terminals that you crimp onto your wires, you put the ring terminal around that bolt, and then you screw it back on with all of the washers. Maybe actually put one washer under. Put one washer under. You put your little ring terminal. You put another washer on top. You put that fucking random ass ring. And then you screw it back up. And so if we look at it with this camera here, this is what it looks like, right? So the connector is pinched in there, right? So I'm going to take 2 channels from the power supply unit, so 2 pluses and 2 minuses, to go onto the same fuse box. So the wires are a bit balanced. Since it's the same fuse box and they're all connected through one singular copper plane, there's no risk of anything else burning than the wires. Like the wires is the weak link of this whole chain. That's why I'm doubling them. And doubling them makes us extra safe, because again, it is for a pretty pricey tech installation piece. And so we should be golden with 2 wires. Now, my problem was that those ring terminals that I just showed you for the fuse box are too big for my crimping tool. The crimping tool is the tool that puts the connectors onto the wires, like it basically crunches them onto the wires. So I went down and I got a regular pins, I don't know how you call that, fucking clamp, I don't know. And I wanted to try and see if it would work. Now that all the explanation is done, basically I take one with one connector on the side, get the insulation out, put everything in to the metal all the way to the end. So if you look at it, it goes all the way to the metal. You most likely can't see. I swear on my life it's going to the metal. And then crimp it a bit with this, so that the crimping tool can actually reach it. So yeah, that's the idea. And then it's not in place at all, but I'm hoping that the crimping tool can now pass through. So put that little bitch ass over there. Otherwise I'm gonna have to go buy another crimping tool tomorrow and redo that entire segment, which I don't want to do. That is not one of the fun parts of the project. Yeah, no, that shit just doesn't work. It is a bit of a nightmare, to be completely honest. Fucking hell, bro. The whole insulation is just going up in fucking smoke. No. So this is not going to happen. Right. I'm going to need another crimping tool, a bigger one. Even though this is said to work until 10 square millimeters, until AWG7. Maybe I can unscrew it. Wait, ooh. I have a bit of an unscrew possibility here. The tool is modular. I repeat, tool is modular. Wait, how the fuck does that work? I really don't understand, to be completely honest. Okay, crimping tool, modular crimping tool. How to modular? You know, the thing probably came with instructions. fuck it. Oh, Esther, wait, Esther, it's been so long. Hi, how you doing? Hi. It probably came with instructions, yes, but I tend to just throw boxes away, which it kind of biting me in the ass right now. But if you know how it works, I'll gladly take help, because it's that motherfucker right here. Right, it's right here, it's this one. And I took a screw out, and it kind of screwed me, if you know what I mean. But yeah, no, I think I'm fucked forever, which is problematic, because I kind of enjoyed the concept of, oh yeah, no, I think it's just more crimping. Yeah, no, I don't think it fits. No, I think I'm fucked. I think I need another crimping tool, which I'm not so happy about. It's another 30 minutes drive, but hey, fuck it. You don't? I was kind of relying exclusively on you. You're the electronics person among us, among both of us. Okay, so that goes into the fucking trash. I wanted to try it, but fuck it. What we're gonna try instead, it's okay, I always have something else planned, is we're gonna do the coding part. So, wait, we kind of skipped a whole explanation of the whole thing. I look fucking batshit crazy. It's all right. A whole part of the explanation is the electronics, the brain, the thinking, the coding, the how is stuff going to, dumbass software engineer just like you. Yeah, okay, all right, well, we're both fucking ruined by AI. It took all of our jobs. And now we're doing fucking electronics in a basement. Okay, so, okay. Everything is gonna happen through the Raspberry Pi 5, which is kind of a beast by itself, and two ESP32s that I have somewhere here. Now, I need to open it to kind of show you how fucking valuable those are. Those are pretty. I didn't cheap out on those fuckers. Those are not scissors. Yet they work. Weird. I want to sell you shit. Okay, there we go. ESP32 with an Ethernet port, and Raspberry Pi with, obviously, an Ethernet port. Now, why is that important? It is important because fuck all of that shit. I don't need all of you in the middle. You are broken blades. You are there. Okay, let's make a bit of space. You know, that's how you work properly, is with a bit of space. Okay, the way this works is we're going to have, so top cam, looking good. Yep, that's where we want you. There we go. The way this whole thing is going to work. The way this whole thing is going to work is I am supposed to have two ESP32s. Anyways, this Raspberry Pi is going to be connected to the internet and to two of those ESP32s. Without the other, it doesn't have as much impact. Wait. Whatever. Fuck it. Anyways, how are they going to be connected in between each other? If we connect them through fucking GPIO pins, that would means that we have to use IC squared, and I don't think you can send as many information as you want. Plus, it looks kind of shitty. Plus, I don't like it. So instead, what we're gonna use is we're gonna use a switch, a network switch. We're gonna connect both of those motherfuckers through Ethernet. That's why those ESP32s have Ethernet. And they're going to communicate through a protocol called UDP. If I'm not mistaken. UPD? UDP. I think it's UDP. That protocol is going to allow me to send information to those two ESP32s that are going to handle the LED channels. So actually, it would be helpful if you could see this. Hey, there we go. Fucking pro streamer. This is a table. This is the table that we're going to have at the end with all the individual rectangles, as I showed earlier. Those are the rectangles, acrylic PMMA sanded rectangles that light is going to be shining through their underside and then diffuse it. When an event happens, the place where the event happens will shine a different color and make waves on this interactive map. The way I'm going to do this is by having LED channels, with materials, very pretty. LED channels, approximately 15 of them if I counted properly. I'm not sure I remember how many there are. And they're going to shine light from under. So 15 LED channels is way too much to handle with a singular, I lost what I want to say, microcontroller, right? So what we're gonna do instead is we're going to have the main brain, which is the Raspberry Pi, and then two ESP32s that are going to control each half of the channels and connect it through UDP, because this has the least amount of delay and can transmit a relatively high quantity of information. Now, how am I going to power all of that computing and brain power? It is still going to be through the 24 volts power supply. Now, how? You're gonna say, if you put 24 volts into a Raspberry Pi, that motherfucker is gonna explode. And you would be right, it's gonna burn up like your chicken when you forget to take it out of the oven. So we have this, which is a buck converter, DC to DC, with a relatively big heat sink on it, because that shit heats up apparently, like a chicken once again. Right, and it converts 24 volts to 5 volts. 5 volts is the input voltage of both the ESP32 and the Raspberry Pi. So what we can do right now, instead of complaining about not having the right crimping tool for the ring terminal to plug in the fuse box, is we can start working on the electronics. So yeah, connecting this to the power supply, connecting the power supply to AC current, which I'm kind of terrified of, to be completely honest. Because I have the connector for the AC current as well. And we also looked, last explanation, then it's time to do stuff. We also have been looking at, yes, okay. This, if I bring back the table and the rectangles, yeah, there we go. This is the plug. The plug, the AC handling plug, this little fucker right here. It's going to be connected to the power supply unit, and the power supply unit, from the power supply unit to the fuse box, needs to have the shortest amount of distance in wires, because as we said earlier, it's kind of a weak point. So this is going to have the most amount of distance in terms of wire. I measured it, it's around 75 centimeters, which is quite a lot. I'm kind of worried about that, especially since it's AC. I don't know if I should be twisting shit, or I have no idea. I never work with AC. So we're gonna see that. We're gonna work on that all together. Fuck OBS. Shit, I hate OBS. Fuck you. Yeah, there we go. Okay, full screen. You go back on top, and you go back in the bottom. Right, so main order of business is this plug has 3 outputs, which are using a certain type of connector, which I should be able to find because I bought them on purpose with my money. Jesus Christ, it was in a transparent plastic box. I need water again. I speak too much. I don't enjoy speaking. Speaking kind of sucks. I think we should communicate with hand sign language. All right. Ugh. I used to have the connectors. I know they're here somewhere. They're fucking with me. They're in a big transparent box. If you've seen it, tell me. I genuinely don't know where I put them. Fucking shit. Because as long as I don't find those, I can't really work, because that's the first thing that we're gonna do. Big transparent box. I keep losing shit. Should I make you watch something in the meantime? I think you guys want to watch something in the meantime. I think you should. Because this is going to take a while longer. Unless I find it now. Or maybe now. It's okay, I can find it now. It's a fucking plastic box, transparent plastic box. It's not in there. It's not in there. It's not this one. I have way too many transparent plastic boxes. I just keep having like little hopeful moments. I'm like, oh, here they are. Oh, they're here. But I thought it was on that table. I really thought it were on the table. Plastic box, approximately this size. Turns out I'm a dumbass. Turns out I'm fucking stupid. Turns out I don't have eyes. Turns out I'm wildly stupid. Jesus Christ. Oh, they're here. There we go. See? Right under my nose. Okay. Ugh. So those are connectors that will connect to the... Oh, why do we have so much today? That will connect to the output of this. So those little hold connectors, those are the male ones, and the female ones look like this. Those are quick connectors, so you can take them on and off. Now, and they have little plastic protections. So why do you want plastic protections? So you don't fucking die, brother. So I think the way to do it is, I don't know, I'm fucking stupid. The way to do it is, yeah, you like crimp the shit, and this is like the insulation, so you don't die by touching AC current. Now, the problem is there are 3 phases. I don't know which one is which. This is not extremely helpful because I cannot read that because I'm stupid. So let's, yeah, this is stroke right there. CW2B 10AT. Let's check it. Let's check it online. You and me, baby. You and me. Let's check it online. Let's check what it looks like. Desk. Okay, yeah. So CW2B 10AT. That's the name of the piece, right? 3-phase current, which is which? I don't know. 3-phase power. Why does one 3-phase electric? I don't, dude. I'm fucking lost. EMI. Yeah, it has electromagnetic interference shield, which means that you get no interference, and it has a fuse inside of it, which means that it's safe. That's the piece. Now I'm gonna guess that top one is top one, left one is left one, and right one is right one, right? That sounds approximately reasonable. But I don't know which one's which. Wait, let me check. I have the cable that goes with this somewhere. I think it's on the floor. Yeah, there we go. And there's another one connected to it. Right. Now, oh, there we go. Okay. So unless they are mixed up around, the indication is on the plug. So you have L, ground, and N, which is I think neutral, line, and ground. And unless they're mixed up from this side to this side, they should match up, but I'm not sure. So what I'm gonna do is I'm going to trust my life with ChatGPT. New chat. I have this piece. That's not what I'm looking for. I have this piece. Whoop. The output is 3 pins. I don't know which one's which is which. The input, however, is labeled as such. Ah! Well, whatever. Fucking. All right, we're entering. Fuck it. Fuck you. On the input side, it's usually labels of L and ground. Yes, indeed. Here's the standard layout you want, usually center or offset. Center is yes, so it's. But the exact physical position, how to satisfy. Set multimeter to continue. Put one I don't want to use. I can AC with a multimeter? Okay, this is the moment where I die live on stream on the internet. Earth usually connects directly, no filtering component in series. Live and neutral pass through the filtering network, coil plus capacitors. Never swap L and N on filtered output when fitting sensitive PSU. If you open datasheet, you can find L in, filter, L out, L in, line load. It looks like this. This is what the fucking the thing looks like, right? Huh. Wait, you can go there. And you get a restart. I guess I'm just gonna multimeter it. Fuck it, no? Yeah. Yeah, fuck it. So, continuity. Set multimeter to continuity beep mode, which is how this works. That's beep mode. Now, put one put on input L. So L is what I think is this one. So this is L, and the other are neutral. That's fun. That one is output L. Oh yeah, I'm fucking retarded. So, we can't use that word. Oh, true, sorry. The way, okay, I know the input, L, N, and ground, right? I know which one's which. So I can just put, the one I know is L, and just check for continuity. And the one that is gonna beep, none is beeping. Wait a second. Ah, Jesus Christ, come on. This is harder than it looks. Literally nothing is working. Okay, the top one is the top one. That's fine. This one is literally nothing. And this one is also literally nothing. That fucking sucks. Huh. Did you flip the switch? Dude, I have the IQ of a newborn baby whose parents were both alcoholics and fucking crack addicts and lived in a cave. Did you flip the switch? Oh, of course I didn't flip the switch. That would be way too easy, wouldn't it now? Now wouldn't that be too easy now? Yeah, genius, yeah, fuck you. Yeah, buddy, okay. Oh, it still doesn't work though. Ha, fuck you. Fuck you, it still doesn't work. Oh, Jesus. Well, maybe the neutral is not working, but the line is gonna work. Yeah, line is working. Yeah, that's the whole thing. Right. Fuck me, man. So I know that line is this one. That's 100% sure. Because the one that comes in on this side is line. Okay, yeah. Do I have a pen to write that shit? Or a marker? Or any other kind of, yeah. Whoopee. That's L. I can't write on metal. That makes sense. I'm stupid. That makes sense. Left is L. L for L. Left is L. Not when looking at it, but fuck it. So left. What is the coloring? Coloring. How do you call that? Colors. AC wires. Line. Neutral, hot, ground. France. What is the colors of the AC wires? Phase, neutre. So neutral is always blue. I'm gonna put it black because I'm stupid. Phase, which is L, is any color. So left is gonna be red. This, I'm guessing, with my whole heart, is top is ground. And so this can only be neutral. So they're not switched, but neutral is not coming through, which is surprising. But fuck it, we ball, right? Oh, wait. Let me check something. Let me use my old brain. Okay, got continuity, because this is kind of a matter of safety. Because continuity for L and G and B, but N not going through. Is that fine? Question mark. Otherwise, I'll try with the other one. No, it's not normal. Okay, I'll try with the other one because I have 2 units. So potentially one is defective. Or I've been lied to, and that's not how it's supposed to work. Fucking hell. Line is coming through. Ground is coming through. And N is also coming through. Yep, this one is defective. Okay, buddy. So they're not changed. They're not switched up, which we like. We love even. We fucking love with all of our heart. Yeah, that's perfect. Yeah, that's perfect. Oh, it's not touching. It was touching. Shitting fucking content. Okay. Just for a reminder, it's my first time working with AC. I've never in my entire life worked with AC. So I like to be extra cautious so that I don't fucking die. This used to work, it doesn't anymore. What the fuck is going on? Oh yeah, that seems too good. Left and right don't work too good in my head. Yeah, all right, fair. Okay. All right. Okay. Okay. All right. Yeah, fuck it. Yeah, fuck it. Okay, so let's go back to nest. Sick. I'll do wiring of this. 75 centimeters, right? That's what we said. I have 3 types of wires. Red and green is ground. If you look at... nearly died over there. Oop, gotta restart this one. Red and green, gotta restart this one. Gotta restart this one. 1, 2, 3. Whoop. Okay. Red and green is ground. It's actually a pretty hard one. I don't know why I bought this, but I did. I need 75 centimeters of it. I don't have anything to measure distance. So we have to figure out an interesting way to figure out 75 centimeters. 75 centimeters is, how much is one power supply? LRS 350/24. LRS 350/24. Spec sheets. Give me the size. Give me. Okay, there we go. 215. Is there anything else? 215. So 700 and wait, we said approximately 1 meter. 1,000 divided by 215. That's 4.6 power supplies. So I just have to put 4.6 power supplies of length of wire is what we're looking to work with. That's one power supply. Two power supply. Three power supply. 4 power supply. And pretty much a half is what we said. Epic. That's approximately 1 meter, which is 75 plus extra leg room in case we need extra leg room. Now, those are going to work with, oh, that's for the power supply. I don't want, oh yeah, I do want the power supply. I need to power the power supply to power the DC to DC buck converter to then power my electronics. Right. So, whoop. Gotta go. Please don't electrocute yourself, or at least not when I'm not watching. I can't promise anything. I'm gonna try. But thanks for stopping by. I'll try. All right. So I need to put connectors in there. We said for the power supply, we said approximately 1 thumbnail of wire for the crimper. So that's going to be the connector. Okay, this is not straight. I need you to be straight. Thank you. Said the transition. I don't know what I'm fucking saying. I need the crimper connectors, 2.5 square millimeters, ideally. Wait, huh? What is going on? Okay, there we go. I need the crimper connectors to connect those wires to the power supply. 2.5, there we go. Whoop, battery saver mode activated. I don't like that. We are plugged in. Okay, so boys and girls, ladies and gentlemen, this is the moment you've all been waiting for. Crimping. Take the crimper tool. I'm gonna go live. Yes, sir. Take the crimper tool. Crimp it. There we go. That's one crimped buddy, little boy time. And the other side is going to be the connector to the AC plug. I shouldn't put this in my mouth. It was in China not too long ago. Not that there's anything wrong with China yet. I think it is unsanitary for me to do so. Now, this is gonna go in, right? Okay, maybe not like this. But then how? Right? That's a bit stupid, isn't it? Oh, wait, no, I'm stupid. I'm stupid, wait. The insulation needs to go with the thing, right? However, first of all, this looks pretty sick. I think I'm gonna put one of those. But I need this to go like that. and then crimp it. Ugh. And it's kind of too big. Oh yeah, because the insulation is still on. Stupid! Stupid! Yeah, you're so stupid. Take off relatively large part of the insulation and then crimp it, right? That does make sense. And so now I should crimp it, but still, like, how the fuck am I gonna put this little plasticky insulation inside? Right? I have no idea how I'm gonna do this. Do I need to already kind of bend it? Am I really that dumb? Possibly. I'll cut a bit more of the insulation first of all, because it's a bit wide. Whoop. The idea is that I crimp this, right? But I need the insulation to go through. But I don't know how. Like those don't fit properly. And I can't really go like, oh, I can't go like this. Oh, that's why this is here. There we go. I'm stupid, but I kind of figured it out by myself. That's what we do. Us smart people. No idea what I'm saying. Yeah, there we go. Okay, that makes sense. That makes sense. Crimp it. So how do you crimp stuff? You have a little crimping tool. Whoop. You take it with a little hand, and then you go. Maybe that's not a right crimping tool either. I've had problems with crimping tools before. I'm not new to this game. Fuck, again? Okay, yeah, I'm gonna start with the, I don't give a shit. I'm gonna start with the pins. I don't know how you call this. This is gonna go around my insulation, because fuck it. I'm crazy. You can't see anything. Yeah, that's about right. Yeah, fuck you. And so now I can actually crimp it properly without it going loco, bongo loco. Now it's fucking crimped. Is it? Doesn't look like it. I don't think it is crimped. It's kind of alright. Wait, is it stuck forever? Oh no, it's fine. Yeah, okay, so. It's kind of crimped. It should be fine. I think we say fuck it. Or I might have ruined the entire thing. Huh. I think I'm gonna get another crimping tool, and I will come back tomorrow for all of that. So we didn't advance much. I just unpacked a lot of things. The previous day were more impactful. I'm getting tired. I also lost, to check if it crimped, pull on it. Well, a bit of it is on the insulation. I kind of, yeah, it wasn't crimped. Oh, but actually maybe now, yeah, no, it doesn't work. It doesn't make sense. Nothing makes sense anymore. I could just do it like that, but it's really fucking ugly, man. Yeah, no, it's not crimped. I think I need another crimping tool for this kind of connectors. Because the crimping tool I got worked really, really well for those, right? But those are not those. Those are different ones. And this crimping tool doesn't seem to be doing the job for both either ring terminals or this other kind of fucking connector. So fuck it, I say. Okay, what we can do. I've been cock blocked by crimping for the entire time. It was not fun. What we can do is we can give up on that for now, kind of clean up a bit, and then I'll take a little break, like 5-10 minutes, and I'll come back and we will start doing the networking. So UDP connectors, Ethernet connectors to both the Raspberry Pi and the ESP32, because there's two ESP32s. So I can start working on this a little bit. And tomorrow morning, I'll go get more crimping tools, and then I will come back to stream the remaining of the crimping, everything that we started today. All right, I'm gonna take a break. I'll see you in 5 minutes, approximately. And wait screen.